So good morning and welcome to the lecture. This is, I think, lecture number 2 in heat and thermodynamics. Well, we just started what is heat and thermodynamics. We discussed the definition of heat. What is heat? Heat is energy that flows. Heat is energy in transit. That is what the term that we used. In transit means it is only defined when it is traveling, when it is flowing from one body to the other body. So I can't say that this body has 200 calories of heat. I cannot say that this body has 300 calories of heat. It is internal energy that we talk about when it is inside the body. But we can always say that 20 calories of heat energy has been transferred from body number A to body number B. That is how heat is defined. Heat is energy in transit. Then we also saw the definition of temperature. Temperature tells us how cold or how hot a body is. It has got nothing to do with heat, because hotness or coldness of a body is not determined by its heat, but it's a type of, it's a function of its internal energy. Internal energy and temperature both are related to each other. If I talk about the internal energy of this body, or for that matter, if I talk about a system which consists of a gas, if I talk about the internal energy of the gas, we talk about the internal energy of the gas. What is the internal energy of a gas? If the gas is contained in a container, how it is related to temperature? Can anyone tell me that? How is the internal energy of the gas, of any gas, related to its temperature? Do you have any idea? How is the internal energy? I hope you have read the term internal energy denoted by the letter U. Do you all know this term U? No response from your end. You have not heard about the term U, internal energy of a gas? Yes, bacha? Not heard about this term? Not heard about this term? Yes or no? If you can't speak, can you type?
The energy present in the body.
Yes, bacha?
Energy present in the body.
How it
Inside
is
the
related?
body.
Okay, how is it related? If I talk about energy of a gas, how is it related to the temperature of the gas? Can you tell me that? How is the energy of the gas related to the temperature of the gas?
Directly proportional to
Can you tell me the formula for that? Directly proportional. Yes. Can you tell me the formula?
F/2 nRT.
Great. F by 2 and RT. What does F stand for?
Degree of freedom.
Good. F by 2 capital N RT. Well done. What does N, capital N, stand for?
Number of moles.
Great. Is there any other way in which I can write the same thing?
Sir?
Is there any other way in which I can write the same thing?
I didn't get you, sir.
Is there any other way in which I can write the same thing? Look at what I'm highlighting.
NCV delta T.
NCV delta T or
Yes, sir.
NCVT? Should I write NCV delta T or should I write NCV into T?
NCV delta T.
No, I should write NCV into T. NCV into T. From here, I can draw a simple reference. What I can draw from here? That CV of a gas is equal to
F/2R.
Okay, F/2R. I hope you know how to prove it. If time permits, I'll let you know how to prove it. Well, let us take, since this is a class where you have previous knowledge. If I have this state 1, this state 2, this is known as the state of a gas. I hope you understand the term state of a gas.
Yes, sir.
State of a gas is something like your state. It's something like the position of any point in space. If I have to tell you the position of any time in space, what should I tell you? If this was any point in space and I had to tell you where is this point in space, what do I need? I would need a coordinate system, yes or no?
Yes, sir.
Then what do I need? I need an origin. Okay, what do I need then? I will need the
Slope. Slope.
I'm only asking location of a point. Why would I need the slope? I would need the x, y, and z coordinates of the particle, of the point. Yes or no?
Yes, sir.
I also need the time coordinate, at what time it is there. Yes or no? So I need 4 coordinates, right? 3 coordinates of space and 1 coordinate of time. Yes or no?
Yes, sir.
We live in a 3-dimensional world. When I say 3-dimensional world, I mean 3 dimensions of time. 3 dimensions of time and how many, 3 dimensions of space and how many dimensions of time? 3 dimensions of space and 1 dimension of time. We live in a 4-dimensional world. Do we understand this?
Yes, sir.
Just give me some time. My camera is giving some trouble, so I'm also trying to rectify it. Okay. To give you the position of this point in space, I need 3 dimensions of space and 1 dimension of time. Now, forget about that. Let us think of this as a state of a gas. To tell you the state of a gas, what all things should I tell you? State of a gas at point 1 is something like coordinate of a point in space. To know coordinates of a point in space, I must tell you x, y, z, and t. X, y, z coordinates and time. What do I need to tell you about a state of a gas? What are the things that define the state of a gas? Any idea?
No idea, sir.
No, you have idea, but you don't know that idea. I mean, you don't know that that idea is same as this idea. You know that. You have heard it 100 times, 1,000 times, maybe 1 lakh times in the 2 years that you have studied. You know that idea. How do I define the state of a gas? State of a gas is defined by something known as state variables. Have you now? Does that word sound familiar? State variables. Do you know this term, state variables?
Yes, sir. We know.
Great. What are those state variables? What are those state variables? No idea?
Pressure, volume, temperature. These are, sir.
Right. Pressure, volume, temperature, number of moles. You can call these 4 as the state variable. Entropy is also a state variable. But let us concentrate on P, V, T, and N because I want to relate it to X, Y, Z, and T. To give the position of any point in space, I need X, Y, Z, and T. To give the state of gas at any point, at what is the state of the gas, I need 4 variables. And those 4 variables are what? Pressure, volume, temperature, and the number of moles. So now things look similar. Yes or no? Things are looking similar. Yes or no? Correct? Things are looking similar to point in space. Yes or no?
Yes, sir.
Right. Now, if I had to draw the point in space, I will call this axis as X and this axis as Y. Yes or no? And I will be drawing Z axis coming outside. Yes or no?
Yes, sir.
Now, I take the same analogy. And now this is not X. This is not Y. If this becomes P, oops. If this becomes P and this becomes V, this becomes a which graph?
PV graph.
This becomes a PV graph. If I draw V on the top on y-axis and temperature on the x-axis, it becomes a VT graph. So everything is similar. Are you getting my point, bacha?
Yes, sir.
Now think it of as of your first chapter. Your first chapter was all about displacement, position, distance travel. Do you remember that chapter? Do you remember that chapter? Displacement, distance traveled, and all those things. Yes or no?
Motion in a plane.
Yes, beta?
Motion in a plane.
Yeah, you remember that chapter, distance, displacement, velocities, and everything.
Yes, sir. Somewhat.
Okay, somewhat is good enough. Now, let us imagine that I am a body and I am moving from here to here. So I am going to, what I'm going to do here is I am trying a new experiment. I'm trying an experiment that I've done this before. It's not new for you. But I'll try to relate this entire thermodynamics, things in thermodynamics to your motion in 1D, something of that nature. Let's see how good or how bad I am at this. Now I move from point A to point 2. Now moving from point A to point 2 is similar to, in some ways, again you have to take analogies. See, physics is all about taking analogies. If you understand one thing, one concept, how can you relate a different concept from this concept? Now these two things will be looking exactly different from each other, but you will understand that conceptually thinking they are same. I mean, no difference. So now me or anybody moving from point 1 to point 2 is now similar to this gas changing its state from where to where? State number 1 to state number 2. Do we understand this?
Yes, sir.
From state number 1 to state number 2. Well done. I'll give you a minute to note what I have told you till now. Okay, no. Right now may not be the right time. Let me make my point and then I'll give you time. I go from point 1 to point 2. Now this green thing that I follow, what do I call it? I call it the path. Yes or no?
Yes, sir.
Okay. Now if I ask you, remember I have to cover entire physics, so I can jump from one topic to the other one. If I'm teaching you heat, that doesn't mean that I'll teach you it only. I'll teach you something else as well. Now, as soon as you hear the term path, go to motion in 1 dimension. Do you recollect anything about path? Anything about path? When you hear the term path, does it remind you of anything from chapter number 1? Does it remind you of anything from chapter number 1?
One dimensional.
Yes, beta, what?
One dimensional.
Is this path 1 dimensional? No, this is a 2-dimensional path. It is moving in a plane. So why do you say 1 dimensional? What do you say 1 dimensional? Okay, can you define what is distance traveled by a body? Can you give me a definition of distance traveled by a body? Fast. This is the most basic definition. Yes. What is distance traveled by a body?
Speed into time. The average distance covered by a body.
Speed into time is the average distance covered by the body. I'm sorry, I've never heard the term average distance. Can you elaborate what is average distance? And how is it useful here? Average distance. How do you define speed? Sure, I'll ask you a different question. See, the name of the topic may be heat, but I'll take the vision of the entire curriculum at my hands. What is speed? You said distance or average distance is speed multiplied by time. Then I ask you what is speed? How do I define speed? Tell me. See, there is no right answer, no wrong answer. I just want to let you know what is theoretically correct and how should you be saying this. If I ask you what is this, you will tell me this is a pen, sir. Yes, sir. But if I ask you to define a pen, you might be in a fix. You know what is a pen, you know what it does. But sometimes you get caught in the definition of that thing. Same thing happened with you. In the previous class, you cannot tell me that you could not clearly define what is heat, you could not clearly define what is temperature. Now, what happens is in day-to-day life, it does not make a difference whether you know the definition of this temperature or not, or whether you know the definition of this pen or not. But in JEE Mains and Advanced, it makes a hell lot of a difference. Because if you don't know the definition correctly, you are caught. And if you're caught, you are done. Okay. You told me average distance, which I have never heard about. Well, I'll try to understand what is average distance. Average distance is speed multiplied by time. Then I ask you what is speed? What is speed? What is the speed of a body? Tell me fast. I don't have time, becha. We don't have time. Tell me what is speed. Okay. I'll again try to make you understand in a different way. Someone asks me, where do I live? I say, in front of your house. Or in front of. Can anyone name? Can I have any of your names? Bacha? Jayant. So someone asked me, Jayant, that where do I live? Where does Aastik sir live? I told him, I live right in front of Jayant's house. Well done. He does not understand. So he again asked me, okay, tell me, where does Jayant live? Then I, use my khurafati dimag and I tell him, Jayant lives right in front of my house. So, wow, great. He does not even understand then where do we live? So then he asked me, okay, where do both of you live? The answer that I gave him is, we live in front of each other. Is that answer making any sense? No, because I'm just confusing, right? Similarly, if I say distance in terms of speed and speed in terms of distance, well, you don't define anything. You don't define anything. You are just playing around and not making sense. So there must be a precise definition of one thing. Now, you cannot define distance in terms of speed, because speed is defined from distance. So how can I define distance from speed? No. It is as good as saying that there is a mother and there is a daughter. The daughter comes from the mother. Okay, the daughter comes from the mother. Mother always remain mother. A daughter cannot become the mother of his own mother. Mother is distance. Speed is the daughter. I can define the daughter in terms of mother. I cannot define in physics mother in terms of daughter. It's all rubbish if I do that. Speed is defined from distance. So distance cannot be defined from speed. That's all. Do I make myself clear, bacha? Am I clear? Distance cannot be defined from speed. Distance has to be defined in some other way. What is that way? Do you know this? What is the definition of distance? It has got something to do with path. Does it ring any bell? Yes, bacha? Tell me. See. Yes, tell me. Tell me.
The length of path.
Yes, now you are correct. Yes, now you are correct. The length of the path. Oh, that is distance, not speed multiplied by time. That is not distance, bacha. It is not distance. This is now you define distance. That is how you can find out something. Find out something. How do I define pen? I don't know. But I can use this pen. I can find out what this pen does. That doesn't mean that I don't know the definition of this pen. I have to know the definition of this pen to understand it correctly and write it in the exam of JEE Main or JEE Advanced. And there's a difference between so-called high rankers and the so-called not so high rankers. Path. Length of the path is distance. I will not write it. You should know this. Length of the path is distance. And therefore, this distance, gentlemen, depends on path. Am I clear?
Yes.
Distance is the length of path. Therefore, it depends on path. There cannot be anything else. Therefore, oops, wrong color I've used. I'm very peculiar about colors. I love colors. I can't name them, but I love them. Okay. So distance depends on the path because it is defined from the path. So it has to depend on path. And therefore, I can call this distance as path dependent. Do we understand this? I'm just using some terms so that these terms can be related to what we are discussing today. So this distance is path dependent. Yes or no? We understand this, correct?
Yes, sir.
Great. So distance is path dependent. Now, once we have talked about this, it's a scalar quantity. I'm not going to get to the depth of what is distance. I'm sure you have done a lot of problems on distance and you are very clear about distance. I just want to make a point and I want you to understand things as they are. I can't sugarcoat them. Now, if I've talked about distance, and there is one more thing that I need to talk about. What is that thing that I need to talk about? Tell me fast. If I talk about distance, what is the next thing that I must talk about? Tell me fast.
Speed.
Tell me.
Displacement.
Yes, bacha?
Displacement.
Yes. I must now talk about displacement. From A to B, I go. Now, again, I would ask you, what is the definition of displacement? Define it.
The shortest path.
The shortest path. Tell me, what type of quantity is displacement?
Vector quantity.
Vector quantity. And I hope you know what is a vector quantity. You know what is a vector quantity, right?
Yes, sir.
Now, again, I ask you the same question. What is displacement? How do you define displacement? Now, give me your answer again.
Displacement is a vector quantity.
Displacement is a vector quantity. Okay, that tells me what type of physical quantity it is. What else do you want to say? That's it. If someone asks you what is distance, you say distance is a scalar quantity, sir. And that is what I know. Pushpa movie. I'm very fascinated by the gentleman L02. पुष्पा फायर समझे क्या? नहीं क्या है वो, फ्लावर समझे क्या? फायर है मैं. हाँ, तो फायर की तरह यहाँ पे नहीं बोलना. We can't speak in fire in the same language here because right now we are students. We are not pushpas. So if someone asks you what is distance, you just don't put your hands on the top of your head and say, sir, it is Pushpa style, that it is scalar quantity. So if I ask you what is displacement, you just cannot say it's a vector quantity. You have to elaborate How do I define that vector? Elaborate. Elaborate. Tell me what is displacement? It's a vector quantity. Okay, I write it here. It's a vector quantity. What else? Just telling it's a vector quantity is not going to serve any purpose. We are not Pushpas, right? We are only flowers right now. We are not fire. I want to get you in, make you fire, but you are not helping me out. Tell me what's the displacement? Someone told me shortest distance. Well, shortest distance. If you say shortest distance, what kind of quantity is distance? Scalar, no?
Yes,
Yes.
direction.
Displacement has direction. Okay. Does that still define what is displacement? We are just moving round. Where is my house? My house is in front of Jayan's house. Where is Jayan's house? Jayan's house is right in front of my house. Where are other right in front of each other? Flower, fire, man. That's we are just moving around the same path. We are not defining displacement. That means we don't know how to define displacement. It's as simple as that. How do I define displacement? If I call this point as A, the one does not look very good here. If I call this point as B, displacement in the simplest possible form, in the easiest possible form, displacement of this body is the vector AB, and that's it. Nothing else, nothing less, nothing more. That's it. It has got nothing in this universe to do with distance. Distance and displacement are so apart and so different from each other that if I ever use the term distance with displacement, I am fooling myself and I'm bringing a disgrace to all the physics grades that have ever walked on this planet Earth. Distance has got nothing to do with distance. Nothing in the wildest imagination. Not even in a Allu Arjun movie, you will find distance and displacement related to each other. They are not, because they are defined totally differently. And if something is defined totally differently, it cannot be referred to each other. So displacement is nothing ever. Don't ever call it as a shortest distance. It's a disgrace to displacement. It's a disgrace to distance. It's a disgrace to physics. No, that's not your fault that you are telling me this. No one taught you that. Now, what happens? Shortest distance, from this shortest distance, whenever we are young, in 8th standard, 9th standard, what happens is, just to make things simpler for us, our teachers define them in a way that they think that we will understand. And that way may be completely wrong. Completely wrong. But that makes us understand. And that thing gets in our head. And we never accept the reality. Displacement has got nothing to do with distance. No. Yep. Someone asks you what displacement, you can say, if I go from point A to point B, displacement is the vector AB, and you are absolutely right in your head, in what you are speaking, and what the other person is understanding. That is the only definition of vectors. That is the only definition of displacement. Now, whenever someone tells me shortest distance, I get annoyed and angry because I have to be. Now, whenever this is how some teachers or someone makes a kid understand what is displacement. But my son is only 7 years old. He's in first standard. Maybe this year or maybe next year, I'll tell him what is displacement. I'll never use the word shortest distance, because if he understands the definition here, this definition, he'll never forget it. And he will never relate displacement with distance, because they cannot be related. Now, if someone is telling you shortest distance, he's trying to make you understand it in a different way. And that way for me is flawed, because as soon as I use shortest and distance, we always invariably in our head are relating displacement with distance. But displacement is a totally different phenomena, compared to distance, and therefore I never use the term shortest distance with displacement. Am I clear, bacha? What I wanted to say or convey? Yes or no?
Yes, sir.
Great. I will not go any further. Now, I'll just stay here. Displacement is the vector AB. Now, this displacement, whether I go from the green path or I go from any other path, does it depend on path? When I go from point A to point B or point 1 to point 2, does the displacement depend on the path? Yes or no? I'm only concerned by the path here, and I just want to relate things. Does the displacement depend on path?
No.
Displacement does not depend on path, so I will call it path independent. Am I clear here? This is path independent. One thing is path dependent, other thing is path independent. Now remember, all these state variables, P, V, T, and N, or the state of this gas is also path independent. Now, what do I mean when I say this path independent? The gas has a pressure, some pressure, gas has some volume, gas has some temperature, and gas has some number of moles. Now, if gas has this particular state variables, the gas will behave in a certain way. Now, how I've achieved this state does not affect how this is going to react. If it is here, it will react in the same way, whether I bring it from here, or whether I bring it from here, or whether I bring it from here. So once the gas is at state 1, no matter how I brought it to state 1, it will always behave in the same way. Do we understand this? Do we understand this, bacha?
Yes, sir.
So all these state variables are path independent. They don't depend on path. This is same as if instead of calling this as a state of a gas, I could call this as a point in space. Now, if this is a point in space, the coordinates are x, y, z, and t, 3 coordinates of space and 1 coordinate of time. If a particle is placed here, it will always behave in the same way, whether I bring it from here, or I bring it from here, or I bring it from here. Once the particle is here, it has a coordinate, whether it is a coordinate x, y, z, or t, or whether it's a state of a gas, it will always behave in the same way. These state variables do not depend on path. They are path independent. Now, apart from these state variables that I've written here, there are other things also which are path independent. And therefore, they can also be called as state variables. They can also be called as state variables because they don't depend on path. They are path independent. Now, apart from P, V, T, and N, can you tell me any other thing which is also a state variable, which does not depend on path? And you know it, and it's written right in front of your eyes. Tell me. Apart from P, V, N, and T, do you know of any other quantity which can also be a state variable? Anything which is path dependent for a gas, for a system, is a state variable. Do you know any other thing that can be called a state variable? Anyone with an answer? No one? Well, the thing is the internal energy of a gas. Internal energy of a gas depends on F, which is the degrees of freedom, which normally remains constant. N is a state variable. So even if you change N, you change the state, you change the internal energy. So this becomes a state variable. So it all depends on N. R is a universal constant. T. So this internal energy of a gas only depends on N and T. N and T are state variables, and therefore And therefore, this internal energy of the gas also becomes a state variable. Do you understand this? Can I have some raise hand that we understand this? Internal energy of the gas is also a state variable. Yes or no?
Yes, sir.
Now, as soon as this internal energy of the gas becomes a state variable, it also becomes
Path independent.
it also becomes path independent. Yes, it also becomes path independent. For example, if the internal energy at this point is UA or U1, and internal energy at this point is UB, UA and UB are path independent, and therefore this internal energy is a state variable. Now when I go from A to B, now this internal energy at point A will be written as F by 2 N R T1. Let me not write it as A, let me write it as 1 so that I can relate it. Internal energy at point 1 is F by 2 nRT1, and internal energy at point 2 will be F by 2 nRT2. Are we all following me? Yes or no?
Yes, sir.
Now, when I go from 1 to 2, internal energy changes. The change in internal energy is delta U. Delta is always change. Do we remember this delta? This delta always refers to change. Delta U is U final, matlab U2 minus U1. And if I do U2 minus U1, I will get F by 2 N R T2 minus T1. And T2 minus T1 is final temperature in absolute scale, Kelvin scale. T2 in Kelvin scale minus T1 in Kelvin scale. But even if I use the Celsius scale here, it will not make any difference, because difference in temperatures on the Kelvin scale and the Celsius scale are same. So in this particular formula, I can use T1 and T2 in the Celsius scale also, doesn't matter. But in this and this, the green one, I have to always use the Kelvin scale. Do we understand this? Can I have some raise hand that we understand this, that we remember this, that we recollect this? So I'm trying to cover everything in the class, and I hope everyone is listening to me. And if there is any doubt, you will ask me. You can also see this lecture again and clear your doubts. So far, so good. Can I have some raise hand that we understand this?
Yes, sir.
Now, if I write it as F by 2 N R T2 minus T1, I can now simply write it as F by 2 N R delta T. Now, to make you understand this delta T, someone told me here that it was delta T. Delta always stands for change. If I write delta U here, then I write delta T here. Do you understand the difference between the two, bacha?
Yes, sir.
U was absolute internal energy. Delta U is change in internal energy. And both of them are very nicely related to each other. Do we understand this? Can I have some raise hand that we understand this? Now, if I just want to write it in terms of du, du will be a very small change in internal energy. How will I write it in terms of du? Du will stand for a very small change in internal energy. I hope you understand the difference. I hope you understand the difference between du and delta U. Do you understand the difference between du and delta U?
Yes, sir.
What is the difference between du and delta U? We are covering everything at the same time. Yes, what is the difference between du and delta U? What's the difference? Between du and delta u, what's the difference?
Delta U equal to change in internal energy.
And what does du mean?
Change is small.
Yes, so that was the difference. This refers to a large change, and this one refers to a very small change. That is the only difference. Now, if I have to write du, how will I write du? I can write du in this fashion. I can write it as NCV into dt, small change in temperature, or I can write it as F by 2 nR dt. So far, so good. Do you all understand this?
Yes, sir.
Remember, delta u or du is path independent, and it is similar to what displacement was in the first chapter. Is this point clear to everyone?
Yes, sir.
Well done.
Yes.
Well done. But now, since we are relating everything to distance and displacement, we have related du with displacement, and it is exactly similar. Now, there must be something that depends on path in this thermodynamics wala chapter. U, internal energy, or delta U, change in internal energy does not depend on path. P, V, T, R, oh God, no one depends on path. All these are state variables. There must be some quantities that depend on path. Can you name them? What depends on path in the chapter on thermodynamics?
Work done.
Work, yes, that is a path dependent. Let me call it as delta. I have always referred to work done as delta because it's always change in position. Work done is a path dependent function. Therefore, work done is path dependent. For different paths, work done would be different. Very easy to understand. Anything else that depends on path in this chapter on thermodynamics? Work done, delta W or dW does not depend on path. Anything else? You know it. You've done problems on it. Delta Q or heat given or dQ in different processes depending on path, this dq or delta u will change depending on the path. Do we understand this, bacha?
Yes, sir.
So both of these things are similar to what distance was in the first chapter, right? So basically what I have to say, if I want to just revise it or rewind it or summarize it, state 1 and 2 are states of the gas. State of the gas is defined by state variables P, V, T, N. All these are path independent. Internal energy is also path independent. Work done, heat given are path dependent, they depend on path. Now when I'm going from A to B or 1 to 2 in a path, here I will carry out a process. That changes. It can be one single process or it can be a series of processes that changes the state of the gas from state 1 to state 2. I will have to do a lot of processes, maybe a single process, maybe a lot of processes. Those processes which change the state of the gas, mark my words, the processes that change the state of the gas or the state variables of the gas. If I change any one of these state variables, the state of the gas changes. Remember, in all the processes that we do, they are done in a closed space, closed system. Number of moles always remains constant. Do you remember this? Yes or no? We normally don't change the number of moles because to change the number of moles, we'll have to take out the gas from the system or put some gas inside the system. There are questions that have come on this also, and we will also do some questions on this. But normally, N, the number of moles, does not change. P changes, V changes, T changes. You can't change any one because all three are related to, all three or four are related to each other. P is equal to nRT. So if you change one, you will at least change the other one. So either you change two or you change three. You cannot simply change the volume of the gas and again sit in आलू अर्जुन स्टाइल की फ्लावर है मैं फायर समझे क्या नहीं उल्टा बोल गया मैंने फ्लावर नहीं फायर है so you can't do that because they are dependent on each other. We understand is that all of these quantities are dependent on each other, so I can't change just one. So I just can't say I will only change temperature and do nothing. No, if you change temperature, something else will also change. Either P will change or V will change. If you can't change P and V, number of moles has to change because all of them are related to each other by an equation which is known as the ideal gas equation. What is ideal gas equation? PV is equal to nRT. That is the ideal gas equation. Number of moles normally are kept constant. R is a constant. So PV, the product of pressure and volume, is directly proportional to temperature. If I change temperature only, P into V ka product will change. That cannot happen. So if I change temperature, out of pressure and volume, something has to change. If I change pressure, out of volume and temperature, something to change. If I change volume, out of pressure and temperature, something to change, or all of these things would change. Those processes which change the state of the gas are known as thermodynamic process. Do we understand this? Can I have some reason that we understand this? Now is the time that you name me some processes, some thermodynamic processes that you know about. Some thermodynamic processes that you know about. Tell me some thermodynamic processes. Tell me. You know them. You have done questions on them. Tell me some thermodynamic processes. You may not have called them thermodynamic processes. That is
Isobaric, isochoric, isothermal.
yes, yes.
Adiabatic.
First is isochoric. You don't change the volume. If you don't change the volume, then what do you change?
Pressure.
And
Temperature.
see both of things. Then there is isobaric. In isobaric, you don't change.
Pressure.
What do you change then?
Volume and temperature.
Third one.
Isothermal temperature is constant.
Temperature is not changed, then what is changed?
PV.
Fourth one.
Adiabatic.
Fourth one.
Adiabatic.
What do you change there?
All will change, sir.
All three changes. Great.
Yes, sir.
Things. Are you able to relate everything that you studied to how everything is related to each other?
Yes.
There's one more which is known as polytropic process. Have you heard about this?
No, but no idea.
Okay, you will have an idea right now. You are in my class, so you will have an idea when I finish the entire chapter on thermodynamics. You will have a fair idea. Don't worry, you will have a fair idea. In fact, I tell you, I mean, in the last, I mean, that was last year actually. We had done a crash course here. And the same question that we did in the class, that same question came in JEE Advanced. Same question. The only difference was I had given the volume as V by 2, and in the question the volume came as V by 4. And there were 6 or 7 questions. I did not cover the entire curriculum because the time was very less. I only had 30 days. I only covered some special topics, and out of those special topics, 7 or 8 questions came exactly on the same line, and one question was cut, copy and paste from my class. So the moral of the story is very simple. If you follow the class judiciously, if you follow the class religiously, not judiciously, religiously is a better word, you will be able to solve any question that comes in thermodynamics. I assure you that. Okay. So far, so good, so clear. So you understand what is state variable, you understand part dependent, you understand part independent, and you know dq and dw are path dependent. Yes or no?
Yes, sir.
So I now quickly move on to some facts. I will be sending you these sheets. Sorry, bacha, yesterday I was just trapped in so much of things and so much is happening here that I just could not send you the sheet. I mean, send sir the sheet. So today I will do that positively. Forgive me for my overlooking. I just had so much on my head, and today was a very in fact, today is also a very busy day, but I'll try to send this by today. Let us go to point number 8 and summarize everything. See, whatever I tell you, most of the things you will find in this sheet. I'll send you 2 sheets. Most of the things you will find in this sheet. If you don't find anything, you have my lecture. If you can make notes, I will not insist on you making notes because I'm going a bit fast. But if you can write running notes, nothing like it. The heat gained or lost by a system depends not only on the initial and final states, remember, but also on path taken. All of you understand this. Heat is a path dependent and it's taken to be positive. If the system absorbs it, and negative if the system releases it. This is time that I can introduce that equation, that famous equation. It doesn't matter how I'm teaching you because I hope you know this. So whatever comes there, I'll just tell you about this. Which equation am I talking about here?
PV equal to NRT.
No, I'm not talking about this one. I am talking about this one. dq or delta q is equal to delta u plus delta w. Do we remember this equation? First law of thermodynamics. Yesterday we discussed this. Yes or no?
Sir.
Or I can write it as dq is du plus dw if I'm talking about a small change. Now, whenever you use this equation, there is a sign convention that you must follow. What is the sign convention for heat? Any heat given or absorbed by the system is still inside me. So that is positive. You understand this?
Yes, sir.
Anything given out, it's gone. So that is negative. So it's just like earning money. Heat is like money. That's energy. Energy is money. Everything is energy. So if it is inside me, if I get it from somewhere, it is positive. If I lose it somewhere, it is negative. It's as simple as that. Clear?
Yes, sir.
What about work done? See, chemistry is different. We are talking about physics here. Even if you can use the same equation in physics and chemistry, you can use your own sign convention. You can use one sign convention. That would be good enough. But chemistry works on a different concept. I could never understand it. That is why I'm teaching physics. Delta W. When is work done by a gas or a system positive?
Work done by the gas is positive. Work done on the gas is negative.
What do you mean by work done by the gas? When do I do work? I am gas. When do I do work? When the volume increases, right? Gas on itself can only increase its volume. It cannot decrease its volume. Yes or no?
Sir.
If I keep it in an enclosed space with a piston on top, the gas on its own can push the piston. Can it pull the piston? No. So when work is done by the gas, the volume increases. So when volume increases, work done is positive. Am I clear with this?
Sir.
I will not take this again because we don't have that much time that I do everything again. So if I do it once, it's done. Delta U. Now talk about delta U. When will I take delta U positive? Physics has logic. Chemistry has a different one. Difficult to understand. When is delta U positive? When the temperature of the gas increases. Will you remember this? Delta U, change in temperature.
Yes, sir.
If change in temperature is positive, if T increases, it is positive. So this is the best way of remembering. If V increases, this is positive. If heat is absorbed or added, it is positive. So all of these are in terms of your positive deposits. Do we understand this now?
Yes, sir.
We'll end this class here. Time is over and I've got another class coming up. So I'll end this class here. I'll see you on the next class tomorrow. Tomorrow is the class. Sunday. Do you have classes on Sunday? No, no.
Sunday exam.
Sunday exams. So best of luck for exams. I'll meet you on Monday and we'll go ahead and I'll send you this sheet by today. Take care. Have a nice day. I hope you enjoyed it. If there is any doubt, you can always ask me. Bye-bye.